Hello everyone, in daily QA series, let's discuss our first question today, which is from numbers. It says the square of how many integers exceed a perfect square by 225. So square of integer, so let's say that square is x square, increases by another perfect square, that is b square. This should be 225, right? So we can say this as x plus y into x minus y will be equal to 225. Now x plus y will be an integer, x minus y will be another integer. Product of two integers should be 225, right? Now how can we write this product of two integers as 225? So one way to write it as 225 into 1, or we can also write it as 1 into 225, or we can also write it as minus 225 into minus 1, and similarly we can also write it as minus 1 into minus 225. So there are four different ways for one variation of product, plus minus, right? Now can we generalize this? Yes, we can definitely generalize this. The prime factorization of 225 is 3 square into 5 square. That means number of factors of 225 will be equal to 3 into 3, which is equal to 9. There are 9 different factors for 225. In how many ways we can write 225 as a product of two integers? So it will be, if you can remember this, if number is a perfect square, the number of ways of writing a number, that number as a product of two of its factor will be number of factor plus 1 by 2, which is equal to 5. So basically we will have 5 unordered pairs, not ordered, unordered pairs. This one and this one are two ordered pairs, otherwise one ordered pair. So there will be 5 ordered pairs where both the numbers are positive, right? So how many ways we can write this? Now for that, let me explain this to you how it works. If we take x plus y as 225 and x minus y as 1, what happens? X plus y 225, x minus y is 1. If you add this, we get 2x is equal to 226 and x will be 113, and so y will be 112. Now as we are taking x square minus y square, we can also take other values of x and y, like minus 113, 112, minus 113, minus 112, 113, minus 112. So there will be 4 different variation for one. So basically 4 different quadrant. We are getting this result as per first quadrant, and there are 4 quadrants, so 4 different pairs will be there for x, y. But in case of perfect square, when this is a perfect square, you need to be a little extra careful. Why? Because there will be a scenario when this will be 15 into 15 or minus 15 into minus 15. And in that case, you get x is equal to plus minus 15, y is equal to 0. In this case, you get x is equal to, only 2 solution. Including both of these two, you get only 2 solution instead of 4. For each combination, we are taking 4, but in this case, there will be only 2 different combinations, so we get 2 different solution only. So in total, number of solution or number of integers as per the question will be, there are 5 different ways. So 5 into 4, 4 quadrant, minus only 2 solution for this one. So there will be a total of 18 different integers. Hence option D is correct. So today we learned 2 different formulae regarding these type of problems. One, in how many ways you can write a number or a perfect square as a product of 2 of its factor, and in how many ways a perfect square can be written as difference of 2 integers. So I hope you understood everything. If not, let me know in the comment. Thank you.